All right, so in this lesson, we're going to learn how to pretty much get the order in which orbitals are filled up just by using the periodic table. So the first thing that we're going to do is we're going to section it off into four different groups. So the first group is going to be these first two columns right here, plus helium. Now, these first two columns are going to be considered as your S sublevel. If we remember from the previous section, we talked about the fact that the S sublevel has one orbital. And we know from the fact that the Pauli exclusion principle that each orbital can fit a maximum of 2 electrons. So if you only have one orbital, that means that the S sublevel can fit a maximum of 2 electrons. Now, we're going to go ahead and separate or count the amount of blocks in each row. So you can see here, in this first row, you have an S orbital. It's going to have 2 blocks. If you go to the second row, 1 block, 2 block, 1 block, 2 block, 1 block, 2 block. You can see right off the bat that each block is representing 1 electron. And then we can go ahead and put a name to each row or each sublevel. So because this first section is in the first row, this is going to be called the 1S sublevel. If you go down a row, this is in the second row, and it's the S sublevel. So this is going to be called 2S. This is in the third row and the S sublevel, so this will be called 3S. This will be called 4S, 5S, 6S, and 7S. You follow the row number, and if you're in these first 2 blocks, or helium, you're in the S sublevel. The next section that we're going to look at is going to be the last 6 columns. So the last 6 columns, minus helium obviously, because that's part of the S sublevel, are going to be considered as the P sublevel. Now if we recall, the P sublevel has a total of 3 orbitals, and we should anticipate the maximum amount of electrons to be 6. If I count the number of blocks in one of these rows in the P sublevel, you'll get 1, 2, 3, 4, 5, 6. And every single one of these rows has 6 electrons total, or 6 blocks. So each block is representing 1 electron. You're going to follow the same rule for naming each individual P sublevel. So this is in the second row, and it's in the P sublevel, so this will be called 2P. This is in the third row and the P sublevel, so this will be 3P, this will be 4P, 5P, 6P, and lastly 7P. Now, moving on to the next section, we have our D sublevels. So the D sublevel is going to be this entire middle section, or where the transition metals are located. Now there is one important rule to know about the D sublevels, and that's that you're going to use the rule of n minus 1. So for S and P, you just follow the row number, and that will tell you the energy level that sublevel is found in. So here, first row, this is called 1S. Here, second row, this is called 2S. Here, second row, this is 2P, this is 3S, and this is 3P. For the d orbitals, however, you're going to subtract 1 from the row number, and that'll tell you your energy level. So this part right here is located in the 4th row, but it's going to be called 3D. The row below it is in the 5th row, however, n minus 1, or 5 minus 1 is 4, so this is 4D. This will be 60, and this will be 70. Okay. And if we were to count the number of orbitals in the D sublevel, you'll get that you have 5 orbitals, which should total to 10 electrons. So if we count the blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We should anticipate to see the same exact pattern come in for the F sublevel. And the F sublevel is found right here in the lantanides and the actinides. These you'll access when you reach these 2 blocks right here. So this will be 57 through 71, or lanthanum to Lu. Can't pronounce that one. And this section right here, 89 through 103, is AC to LR. Now the rule for the F sublevel is n minus 2. So you're going to subtract 2 from the row number, and that'll tell you your energy level. So when you get to 57 through 71, or L8 to LU, you're in the 6th row. However, the rule is n minus 2. So 6 minus 2 is 4. So this section right here is called 4F. Same thing goes for this one. 89 through 103 is located in row 7, but the rule is n minus 2. So 7 minus 2 is 5F. And for the F sublevel, you have 7 orbitals or 14 electrons. So if we count the number of electrons, you'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this section right here is for the D sublevel. Okay. Now, this is kind of a mess, so I'm going to use a clean periodic table, and we're going to use this to our advantage now. So here's one that has every single sublevel pretty much written out for us. So what we can use that information for is we can actually figure out, just going row by row, the order in which these energy levels or these sublevels are going to be filled up. Because remember, the Aufbau principle states that our lowest energy levels are filled up first. Well, the lowest energy level is found right here. This is n is equal to 1. Then you would go to n equals 2, then n equals 3, then n equals 4, and so on and so forth. So you're just going to go row by row in order to actually figure out which orbitals are filled up first. So to start off, in the first row, you can see that you only have the 1s orbital. So first row is going to be, or first energy level that gets filled up is 1s. After that, you've completed the first row, so you move on to the second row. The second row is comprised of the 2s orbital and the 2p orbital. Going from left to right, it obviously is that you fill up 2s and then 2p. So the next set of orbitals that are filled up are 2s and 2p. Once you reach 2p, you are done with the second row, or the second energy level, so you can move on to the third row. The third row is comprised of 3s and 3p. So the order that you'll fill those up in is 3s followed by 3p. The fourth row is comprised of 4s, and then this is where something different happens. Once you go to 4s, you're going to go down to filling up your 3d orbitals and then back up to 4p. So this is a little bit of a thing that d orbitals do, where they are occupied after the energy level of s afterwards. So it goes from 4s down to 3d, back up to 4p. Remember that 4s and 4p do still have higher energy values because they are of higher n values. I'll do the next two rows and I'll kind of cap it off there. So fifth row is comprised of 5s, 4d, and 5p. And then lastly, we have our sixth row, which is going to be 6s, then 4f, then 5d, and then 6p. So it'll be 6s, 4f, 5d, and then 6p. Okay? So as long as you follow the order in which the periodic table goes and you're properly organizing your orbitals, you should be able to just use the Aufbau principle by just using this. So you don't have to memorize that diagram that was shown in the beginning. Okay.